Okay, welcome. As I said, we would be having some review this week. One of the things that I can assure you is on the benchmark is converting from one metric unit to another. We use the acronym King Henry died unusually drinking chocolate milk. Okay, I call it the swoop method. Okay, remember, if there's no decimal place, you can put one behind the last number. Adding the decimal point doesn't change anything. Adding extra zeros doesn't change anything. When they ask you to convert, you can write this down. King Henry died unusually drinking chocolate milk. You find the starting place. This one says milli. So I'm going to look over here where it says milli. I'm going to find where it tells me to go to, which is grams. That's the base unit. I'm going to count how far I move and in which direction. I move 1, 2, 3 swoops this way. So when I solve this problem, I'm going to do the same thing. I'm going to move the decimal 1, 2, 3 swoops that way. Okay, the answer would be 2 grams. Also important for the benchmark is that you recognize units and what's used to measure the different units. Length is the distance between 2 points. Base unit is a meter. We use a meter stick or a ruler. Mass is defined as the amount of matter in an object. Base unit is grams. We use a balance beam to measure mass. Volume is the amount of space something takes up. It's measured if it's liquid in liters or in cubic meters, cubic centimeters, cubic millimeters. We use a graduated cylinder like this or a ruler. Weight is the measurement of the force of gravity on an object. In the metric system, it's measured in newtons. We use a scale to measure weight. A thermometer is measured in degrees Celsius or Kelvin in the metric system. In the standard system, it's Fahrenheit. We use a thermometer. There will be problems on density. Density is the amount of matter or mass in a certain space. When you solve these density problems, Okay? The formula says density equals mass divided by volume. You can use this triangle. If the numbers are on the top and the bottom, you divide. So this is like a fraction bar. So it says literally density equals the mass divided by the volume. If the numbers are next to each other on the bottom, you should know you need to multiply. Numbers that are next to each other in math, we multiply. So density times volume would equal the mass. Okay, so the examples we did before, if the numbers you know fill the triangles, so the one's on the top, one is on the bottom, we divide. The numbers are next to each other, we multiply. So here was a quick example, calculating density when you got two of the three parts of the triangle. Decide what the question is asking, fill out the parts of the triangle you know, use the triangle to help you do the math. Okay. So we have an example problem here. It says, what is the sample of fluid has a volume of 30 milliliters and a mass of 90. What is the density? What is the density is the question. So we're going to put a question mark where we see density in the triangle. 30 milliliters is volume. So 30 milliliters goes in the bottom. 90 grams is mass, so it goes on the top. Numbers are on the top and bottom, so we know we need to divide. Okay, your problem is right here. 90 divided by 30. So we take 90 divided by 30, and that equals 3. This is our unit right here. Grams divided by milliliters. It's just like if this was 90x divided by 30y. Okay? In algebra, it would be 3x divided by y. The units work the same way. It's g divided by ml, just like if it was x divided by y. Okay. Calculate the mass of a wooden block. It has a volume of 50 centimeters cubed and a density of 6. Okay. When it says calculate the mass, that's what they want you to do. That's the problem. Okay. So it's asking you to find mass, so we're going to put a question mark where we see the mass is in the triangle. 50 centimeters cubed is the volume. Okay, think about a cube. It tells you how much space it takes up. So we're going to put that where the B is in the triangle. 6 grams per centimeter cubed says it's the density. It tells us right here, density of. Okay, so we're going to put that in the density box. The numbers are next to each other on the bottom of the triangle, so we multiply. We're going to have 6 grams per centimeter cubed times 50 centimeters cubed. The centimeters cubed cancel off. What's left is grams. And that should make sense that the unit for mass is grams. One of the things that's covered on the benchmark is how to make a line graph. So we're going to review page 8. When you make a graph, you identify the IV in the experiment. The IV is the independent variable. It's the one that's independent. It's the one that you get to change. The dependent variable, the independent variable is graphed on the x-axis. So it's going to go down here at the bottom. The dependent variable, what depends on the independent variable, goes on the y-axis. So we did an experiment to find out how fertilizer affects plant growth. Fertilizer is what's independent. It's what we can change. We think that the plant growth might depend on how much fertilizer the plants get. So the x-axis is where the dependent variable would go. This would be the plant growth in that example, and the amount of fertilizer would be on the y or on the x-axis, the independent variable, what we would have had control over. You always need to make sure there's units on the axis. Classification of matter is on the benchmark, so we're going to review page 12. The graphic organizer kind of sums up everything in the unit. First off, we need to remember that matter is everything that has mass and volume or takes up space. Okay, this isn't fancy like last year where you had domains and kingdoms and phylums. Okay, when we look at matter, it's either pure or it's not pure. Okay, like it's really simple. Okay, if it's pure, it's called a pure substance. There are two kinds of pure substances. One of them is elements, which we're beginning to study on the periodic table now. So that's how we know if something is an element. We find it on the periodic table, and all the atoms are alike. So, for example, oxygen is an element. We can have pure oxygen. Gold is an element, and we can have pure gold. Hydrogen is another element. It's on the periodic table in the first box. It could be pure. The other kind of pure substances are compounds. We'll know something is a compound if it has a formula. Water is a compound. Its formula is H2O. It can be pure. Carbon dioxide, like what's used in CO2 cartridges, can be pure, and it has a formula. Its formula is CO2. If things are not pure, and they're mixtures, there are two big groups of mixtures. The first kind is called homogeneous. That's where the mixture is the same all the way through. If that homogeneous mixture is a solid, it's an alloy like metal, which means you need to melt two metals together. While they're liquid, you stir them, and they get evenly blended all the way through. So like jewelry. The gold in most jewelries is an alloy. It's like 18 karat gold or 14 karat or 12 karat. That means that it's not pure gold. It's not pure gold because it'd be too soft if it was. So they mix it with another metal. And then if you look at the ring or whatever's made out of the gold, it's the same all the way through. That's what the homogeneous means. If it's a solution, it could either be a liquid or a gas. Light will pass through these solutions if it's a liquid or a gas. Kool-Aid or salt water, where it's evenly mixed and it looks the same all the way through. Air in your room, the air is the same and it's evenly mixed all the way through. If the mixture is uneven, it's heterogeneous. That's what hetero means, different. Like if you're heterozygous, you have different alleles from your parents. If it's a solid, it's just some kind of uneven mixture like trail mix or raisin bran. If it's a liquid or a gas, there are two special kinds of heterogeneous mixtures. Colloids, which scatter light, okay, and they don't settle. So things like smoke, milk, jello. The other kind is when the particles are even bigger. They're so big that they settle to the bottom of their container, like muddy water, a river delta, or a pond. So the particles get bigger as we go from left to right. Elements or single atoms. They're the smallest particle that could be. A compound is two or more atoms bonded together. Then we have these solutions where we have compounds mixed with other compounds, and they're mixtures. So the particles are bigger. The solutions in the homogeneous mixtures are the smallest of the mixtures because they're evenly blended like these and light can pass through. Then they get a little bit bigger in a colloid, like in milk, but they're not settling yet. And finally, the particles are so big in a suspension that they settle to the bottom.